fundamentals I covered in the last module and use them to implement client-side caching. In the last module, I explained to you what Angular interceptors are and how to implement them in your apps. I showed you a couple of useful, but admittedly simple cases when you might use them. In this module, I'm going to show you how to combine your understanding of Angular services and interceptors to implement application-specific caching that can really improve the performance of your apps. There's no new syntax to learn in this module, so I'll primarily focus on how to put the pieces together that you already understand to form a useful solution. Before I get into the implementation details for an interceptor cache, I want to talk briefly about the benefits of caching and a few different types of caches. The primary reason for implementing any sort of cache is to improve the performance of your app. That can manifest itself in several ways. Cached HTTP requests provide an HTTP response without actually making a network call to the server. This reduces network traffic, and less traffic means less contention for limited bandwidth and less time spent waiting on calls to complete. Each request that can be returned from a cache is also one less request that must be processed by the back-end servers. The result is a smaller load on your web servers, database servers, and any other resource that might be required to service a particular request. All of these benefits contribute to the most important performance improvement, and that's the improved responsiveness of your app that your end users will experience. Strategically adding caching to your app can just make the whole thing feel snappier. The two most common types of caching we web developers take advantage of are browser caching and server-side caching. Browsers are great at caching resources your site needs, but it can be cumbersome to control the behavior of the cache at a very granular level. Server-side caching can take some load off of your back-end storage systems, and you can exert a lot of control over exactly how the cache is implemented. The drawback is that it's a server-side cache, and that means you still need a call to the server. I think implementing an application-specific client-side cache using the technique I'm going to show you gives you the best of both worlds. The cache is on the client, so your app remains responsive, and you have a lot of freedom to control exactly how it works in order to maximize the benefit it provides. In the next clip, I'll give you a high-level overview of how this can be implemented with interceptors. I used a similar slide to this in the last module to explain how interceptors work. I've updated it slightly to show how an interceptor can facilitate caching. Imagine our client application here on the left and the server on the right. The interceptor and the cache conceptually sit between the two, even though we know they actually reside on the client. You saw in the last module how to implement an interceptor. The cache will be implemented as an Angular service that can maintain a list of the items we want to be cached. When the client makes an HTTP request, the interceptor will grab it and check the cache to see if it already has a response for that request. If so, the interceptor retrieves it from the cache and then sends it back to the client. The request never goes to the server. Let's now look at the alternative situation. A request is made from the client. The interceptor checks the cache but does not find a valid response. The interceptor will then forward that request onto the server to be handled normally. When the server response comes back to the interceptor, it will store that response in the cache before sending it on down the line to the client. When that same request is made again later, it will be retrieved and returned to the client from the cache. Since the cache is just a service, you could really use it from anywhere. However, the great part about pairing it with an interceptor is that the code actually generating the HTTP request can continue to make as many requests as necessary, while all of the work to utilize and manage the cache is delegated to the interceptor. The Angular service that implements the cache obviously plays a pretty important role in this process. Its primary job is to provide a data structure that can store the cached items. I'm going to store each cached item as a property on an object. The service also needs a very simple interface for interacting with the data structure. It needs a method that lets you add items to the cache, retrieve items from the cache, and remove items from the cache. You may also hear this referred to as cache invalidation. It's really just the process of removing items from the cache so that future requests for that item will be supplied from the server. In the next clip, I'll build a simple cache service that will store HTTP requests made by the Book Tracker app. In this demo, I'm going to start implementing a caching solution by building the cache service that will store the HTTP request. The service will just be a very ordinary Angular service, so I'm going to use the Angular CLI to create it. I'll do that from the terminal in Visual Studio Code. The command I'm going to use is ng-generate-service. I'll put the service in the Services folder and name it HTTP cache. I don't want any unit test right now, so I'll set the spec option to false. Let's take a look inside the new file. It's pretty basic right now, but it's a good starting point for our caching service. The first thing I'll add to it is an import statement for Angular's HTTP response class. It's in the HTTP module. That's the only thing I need to import right now. I need an object that can be used internally to store all of the cached items, so I'll declare a new private property named request. I'll declare that it has the any type and initialize it with an empty object literal. I'm now going to write the methods that will make up the API for the cache. We obviously need a way to put things in the cache, so I'll start with that. I'll add a method named put that takes two parameters, the URL being requested and the HTTP response that will be cached. I won't have this method return anything. There are lots of different ways you could create and manage an underlying data structure for something like this, but I'll store the cached items by adding properties to the request object using the URL as the property name. The response to be cached will be the value assigned to the dynamically added property. That's all the code I need to add a new item to the cache. Now I need a way to get an item from the cache. For that, I'll add a new method named get. It will take a URL as a parameter and return either an HTTP response object if one is found in the cache, or undefined in the case that there was nothing cached for that URL. All I have to do is return the value assigned to the property with the name of the URL passed in. If it exists, this will return the HTTP response stored for that property. Otherwise, it will just return undefined. Okay, I now want to add a couple of methods to invalidate items in the cache. Imagine that a request for all books got cached and then someone added a new book. The cached response for all books is now out of date, so I don't want to return it from the cache. I want the next request for all books to get a fresh copy from the server. These next two methods will let me remove items from the cache to support that kind of behavior. I'll name the first one invalidate URL, and it will take a URL as a parameter. It will let me remove a single item from the cache, the HTTP response stored for the URL being passed in. I'll just set the value for that property to be undefined. The last method I want to add will let me invalidate the entire cache with one method call. I'll name it invalidateCache. I'll have it simply assign a new empty object literal to the request property. That effectively gets rid of anything that was in the cache. Again, there are lots of ways to implement something like this. I'm keeping this one purposely pretty simple so we can primarily stay focused on the important concepts I want you to understand. Okay, that gives us all of the basic functionality we need. I can put items in the cache, get them back out, and remove one or all of them as necessary. In the next demo, I'll create a new interceptor that uses this service to manage the caching for the Book Tracker app. In this demo, I'll finish building the caching solution by adding the interceptor that will make calls to the cache service. I'll start by adding a new file for the interceptor. I'll name it cache.interceptor.ts. I'll use a couple of code snippets to add a lot of the basic interceptor code you saw in the last module. This one just adds all of the import statements I'll need. It's pulling in all of the HTTP classes I'll need, as well as the tap and of methods from RxJS. I'm also importing the HTTP cache service I created in the last demo. I'll use another code snippet to stub out the class itself. There's nothing here you haven't seen before. It's just the basic code for an interceptor. Do note that I'm injecting the HTTP cache service into the constructor so I can use it in this class. I've also added a few comments so you can go ahead and get a sense for the functionality I'm going to add to the interceptor. Let's now add some code to each of these comments. The first one says to pass along any non-cacheable request. I'm only going to cache requests submitted with the HTTP GET verb, so I want to do a check here for that. If the request uses anything other than GET, then I can effectively ignore it and pass it on to the next interceptor in the chain. I'll use an if statement to check the method property of the incoming request. If it's not GET, then I'll just pass the request on to the handle method. I want to stop for just a minute and talk about cache invalidation strategies. Deciding when to remove something from the cache and force the app to get a fresh copy from the server is completely dependent on the requirements for your specific application. You can make those rules as simple or as complex as you need to in order to provide the best experience for your users. I'm going to implement perhaps the simplest strategy possible here just to demonstrate the important concepts. I know that the Book Tracker app only submits requests using the GET, POST, PUT, and DELETE HTTP verbs. I also know that any request using POST, PUT, or DELETE is attempting to modify data in some way. Therefore, any request with one of those three verbs will potentially render the data in one or more of the cached responses invalid. I could check the specific URL on the request and just invalidate the related responses, but that's more code than I want you to have to be bothered with right now. Instead, I'm just going to invalidate the entire cache if the incoming request is not a GET request. To do that, I'll just add a couple more lines of code inside this if block. I'll first log that I'm invalidating the cache and output the HTTP verb and URL of the incoming request. I'll then call the invalidateCache method I added to the HTTP cache service. That will remove everything from the cache. Since this bit of code now does a little more than just pass along non-cacheable requests, I'll update the comment to note that it also invalidates the cache. Okay. If the execution makes it down to the next comment, then we know we're dealing with a GET request. The first thing I need to do in that case is retrieve any cached response associated with the incoming URL. I'll pass the incoming URL to the GET method I wrote on the cache service and assign the return value to a variable named cached response. I now need to see if I got a valid response from the cache and, if so, return it. I'll use a code snippet for this bit. If I got a valid response from the cache, I first log a message to that effect along with the URL associated with it. I then log the cached response itself. I want to show you that it looks just like the response that would come back from the server. Finally, I wrap it inside an observable with the RxJS of method and return it to the calling code. One important thing to note here is that I'm returning a value without calling next.handle as you've seen me do in the other interceptors I've written. You're not required to pass the request along to the next interceptor if you already have the value you want to return, as I do here. Okay, if I didn't get a valid response from the cache, I need to send the request to the server and then add the subsequent response to the cache. I'll use another snippet for that. I send it to the server by passing the request to next.handle. I'm then processing the response using the same technique you saw me demonstrate in the last module. I use the RxJS tap operator and see if the HTTP event passed in is an HTTP response. If so, I log that I'm adding a new item to the cache and then pass the URL and the response to the put method on the cache service. The response is also returned from the interceptor and makes its way back to the calling code. That's all the code I need in the interceptor. I now need to provide it in a module. I'll open the core module again and import the new interceptor class. I'll then copy and paste one of the other interceptors in the providers array and update the copy to use the cache interceptor class. I'm now ready to test it out. I'll start the app in the terminal. Once it's running, I'll again go to my browser and open localhost:3000. I'll open the developer tools and refresh the page so we can see the request that went to the server to retrieve all the books. You can see it here at the bottom of the list. I'll now clear this out so we don't get confused about what requests go with what page. I'll now take a look at the console. We can see that it contains a log message reporting that an item was added to the cache. It's the response for the request to /API/books. I'll now clear this as well. I'll go back to the Network tab and then click on the Add Book link just as a way to navigate away from the dashboard. Clicking the Book Tracker link to return to the dashboard loads all of the books successfully, but notice that there are no new requests to the server down below in the developer tools. Back on the Console tab, there's a message that a cached response was returned for API/books. Remember that I also logged the cached response, and that's what you see below this message. It came from the cache, but notice that it's still an HTTP response object exactly like the one that originally came from the server when the app loaded. Okay, let's now test invalidating the cache. I'll clear the console again before doing that. Remember that my simple invalidation rules require sending a post, put, or delete request. I'll add a new book which will generate a post request. I'll add the book Corduroy by Don Freeman, which I deleted earlier in the course. I'll click the Save button, which generates the request, and you can see that one of the log messages down below reports that the cache was invalidated as a result of the post request to /API/books. When the next request is made for all books, it should go all the way to the server again since they won't be found in the cache. I'll clear the console again and test that by going back to the dashboard. All of the books show up, including Corduroy, and a message in the console reports that the response with the books was again added to the cache. On the Network tab, I can verify that a request did, in fact, go all the way to the server. The first of these requests was the post that added the new book. The second is the request that retrieved all of them when I returned to the dashboard. Looks like it's all working as expected. I told you earlier that interceptors are one of my favorite Angular HTTP features, and I think that caching is one of my favorite ways to take advantage of interceptors. With very little code, you can strategically cache requests which reduce the load on your servers and, more importantly, provide a better experience for your users. I hope you'll give them a try in your own apps. In the next module, we're going to shift gears a little bit and talk about testing your HTTP request. Right? Okay, good. Well, after watching the next module, you'll have no excuse not to request as well.